Alright, let's talk JavaScript. Have you ever needed to make your code just wait, or maybe repeat a task every few seconds? Well, today we are jumping right into the essential tools that give you control over time itself. Set timeout and set interval. I mean, it's a really fundamental question, right? We don't always want our code firing off instantly, line by line. Sometimes we need a strategic pause, a delay before something happens, or maybe an action that repeats. So how do we actually tell JavaScript, hey, don't run this function right now, run it a little bit later? So here's our game plan for this explainer. First, we'll cover what code scheduling even means. Then we'll get into the two main players, set timeout for one-off tasks and set interval for repeating ones. Then the fun part, we'll pit them against each other for precision, and we'll wrap up by exploring some of the really weird but important quirks of how JavaScript handles time. Okay, so let's get right into it. At its heart, code scheduling is all about taking control of the when. Normally, a script just runs from top to bottom, bam, bam, bam. But with scheduling, we're basically hitting pause, setting timers, and telling our code not just what to do, but exactly when to do it. Now, the official term for this is scheduling a call. It's just a fancy way of saying we're setting up a function to execute after some kind of delay. And here's a cool bit of trivia. Set timeout and set interval aren't actually part of the core JavaScript language. Nope. They're given to us by the environment the code is running in, like a web browser or Node.js. First up, let's talk about set timeout. The easiest way to think about this is like setting a single one-time alarm on your phone. You tell it to go off in 5 minutes, it goes off, and that's it, it's done. It's the perfect tool for any single delayed action you need. The syntax is actually pretty simple. First, you give it the function you want to run. Second, you give it a delay in milliseconds. And remember, 1,000 milliseconds is 1 second. And after that, you can tack on any optional arguments you want to pass to your function when it finally gets called. Let's look at it in action. Here we're telling set timeout to call our say hi function. We're telling it to wait 1,000 milliseconds, so 1 second. And we're also passing along the arguments hello and John. So what happens? After a 1 second pause, an alert pops up that says hello John. Easy as that. Okay, now listen up, because this is a classic mistake. I mean, everyone does this at some point. You have to pass the function itself to timeout, not the result of calling the function. See the wrong example with the parentheses? That runs say hi immediately and passes its return value, which is undefined, to the timer. Nothing gets scheduled. You have to pass the function name, a reference, itself. So what happens if you set a timer and then change your mind? No problem. When you call set timer, it actually gives you back a unique number, a timer ID. You just save that ID in a variable. Then, if you decide you don't want the timer to run after all, you just call clear timer and pass it that ID. It's like it was never even set. Alright, on to our next tool, interval. So if set timeout is that single alarm, set interval is like hitting the snooze button over and over and over again. It's built specifically for actions that you need to repeat at a regular interval. And hey, would you look at that? The syntax is literally the exact same as set timeout. You give it a function, a delay, and any optional arguments. The only difference, and it's a big one, is the behavior. Instead of running just once, this thing will fire repeatedly with your specified delay in between each run. In this example, we're doing something pretty cool. We start an interval set that's going to pop an alert that says tick every 2 seconds. Now that would get annoying fast, right? So we also set a timeout to run after 5 seconds, and its only job is to call clear interval to stop our repeating tick and then show one final stop alert. So if you need something to repeat, you kinda have 2 ways to do it. But which one is the right way? Well, as we're about to see, when precision really matters, the answer might not be what you think. So let me just ask you, think about it. If you need a task to run with a very specific, guaranteed pause between each execution, is interval set really the best tool for the job? Or is there a better, smarter way? And here is the absolute crucial difference. Interval set is kind of relentless. It doesn't care how long your function takes to run. It just tries to launch it every delay milliseconds, no matter what. A nested set timeout, however, is way more polite. It only schedules the next call after the current one has totally finished its work. This timeline just illustrates the problem perfectly. With interval, let's say our function takes 30 milliseconds to run. We told it to run every 100 milliseconds. But look, the actual pause between the end of one run and the start of the next is only 70 milliseconds. The function's own execution time is eating into our delay. Now compare that to the nested setup timeout way. Our function runs, it takes its 30 milliseconds, and only then, after it's all done, does it schedule the next run for 100 milliseconds in the future. This is the key takeaway. This method guarantees a fixed delay between runs, which makes it way more precise and a lot more flexible. All right, now for the fun part. Let's get into some of the weird stuff, some of the quirks of how JavaScript's timing works. Because trust me, time in JavaScript isn't always as simple as it looks on the surface. So what on earth happens if you write set timeout func 0, a delay of 0? You'd think it just runs immediately, right? But nope. What it actually does is it tells the browser, hey, run this function as soon as you possibly can, but only after you've finished running the main block of code that you're currently working on. Okay, so take a look at this little code puzzle. First, we schedule an alert for world with that 0 delay. Then right on the very next line, we have a regular immediate alert for hello. So what do you think? What happens first? Even with that 0 millisecond delay, the answer is hello will always appear first. Why? Because that 0 delay timeout has to get in line and patiently wait for the current script, which includes the hello alert, to finish its job completely. And this is just so important to remember. Scheduling is not a guarantee of perfect timing. The real world gets in the way. If your computer's CPU is totally overloaded, or if your browser tab is in the background, your timers can get seriously delayed. Browsers even have their own rules, like enforcing a minimum 4 millisecond delay on timers that are nested too deeply, just to protect performance. So let's boil this all down to a simple cheat sheet. Set timeout. Use it for a single one and done delayed task. Set interval. It's fine for simple repeating stuff where perfect precision doesn't matter. But for precise, reliable, and flexible repeating tasks, you should always use the nested set timeout pattern. And there you have it. You now have the fundamental tools to control the flow of time in your code. You can build smooth animations, you can check a server for new data, you can create all kinds of complex timed interactions. The only question left is, what are you going to build?